we have started working on building out a full demo app on Linux. Now, in this video, we're going to be building out our SQL database content to support that application. This video is part of a series dedicated to developing C# applications on Linux. Along the way, we're getting a better understanding of how Linux works and how to make our apps truly cross-platform. If you haven't already, subscribe to this channel to stay informed of new episodes as they come out. And if you're looking for even more .NET, SQL, AI training, and more, go to imtimcorey.com. Okay, let's jump over to Linux. And we have here, I've opened up in VS Code, the Tiny Ticket app. And we haven't really defined this. This is a really small, tiny application. So we haven't gone to the full development process. We've kind of mapped out and opened up Aspire and started that way. And what we're going to do today is build out our database, which again, we haven't gone through and modeled. Now, I would encourage you, whenever you're building an application, don't start by doing a file new project. Start by planning things out. I've done that in my head. I haven't shared that in video because that's not really the focus of this particular building of the app. We're focusing on working on Linux. And so to do that for this little application, it's going to be tiny. And the purpose is not to have this really complex application. The purpose is to show off various parts of how you'd work with different things on Linux. In this video, we're going to see how to work with a database. So we've already seen our SQL server. We connected to our Docker SQL. Now, because we're using Aspire, we could have Aspire just build for us a SQL container and build off of scripts a SQL database as well. And that'd be pretty simple because then we could just say, hey, build that out, and it just does it for us. And then in production, we would just swap that out for our actual production database. But I'm not going to do that. I'm going to do it by hand. I want to show you how to build a database by hand and then how to connect to it by hand. So you know how to do that on Linux. So that's why I'm doing it this way. So Docker SQL. And in here you have one database. We developed the people DB. We're going to develop a new database that is really simple. So we're going to say new database, and the database name is going to be ticket DB. Owner is default. It's going to be SA. So we could say SA just because, but that's it. Compatibility level, we're at 2025. Cool, that works. And we're going to say create. So now we have our ticket DB. And we're going to have one table. So let's go ahead and create a table. Now, the other way of going about this is to use the SQL Server data tool, I think SSDT, which is right here, database project. And we could create a database project, and then we could, attach that to our solution. And I would encourage you to use that. For this video, we're not going to. I want to do it all manually, but the database project is a great way to put your database into source control and have it be part of the deployment system without using Entity Framework. So I'm not a huge Entity Framework fan because of the fact that it gets abused so much and it's so difficult to use well. A lot of people use it, not many people use it well. So I typically use Dapper and connect to my database directly that way. And to do that, people say, well, but you gotta, build out your whole database manually, which is even easier now that AI can help you with the grunt work. Just make sure you check your work. But the other benefit here is you can put that into a database project, which then can be put into source control. You can have it, do the upgrade for you as part of your CI/CD process and so on. That's a totally separate video that we'll probably do at some point. I've done it before, but we'll probably do it again with these new tools. But just know it's possible. And the way we're building right now is manual. And it's going to mimic what you already have probably in production. But you can create, down the road, you can create a SSDT project or a database project type off an existing database and just say import this database, and it takes care of all the scripts for you. So that's also a way to go. And then you can continue to manage that existing database going forward. Anyways, not a lot to say. We're going to do it by hand. So we're going to create one table. We're going to call it tickets. So we have our one table, and we have ID, primary key, identity, cool. And you can either let's do this. Let's say new. Let's do it using the designer. I believe you can come down here and modify too, and I tend to do both. But I'm just going to do it in the designer. So our tickets, we're going to have ticket title, and let's just add our columns for now. I'll close. You know what? Let's just shrink it down. We have our ticket description. We're going to have our date created, and then let's add a couple more. Date completed, and then we have one more down here. Make it priority. Okay, so this is going to be a really simple help ticket or similar type system, but we're going to have one table, one. And that table is going to be just the table for containing the tickets. Notice you don't have anything like authentication or which user and all this other stuff. You'd have to create a massive database of a lot of stuff. We're not doing that. This is a simple one-person use it system that's going to just track title and description, really, and when it's created, and then date completed will tell us if it's null, it will mean that it's not yet completed. If it has a date, it's been completed. So really simple stuff. Priority, this is a fun one. It's going to be we'll not say null here. We're going to have a default value of 5. And that default value just means that it's the lowest priority. 1 through 5 priorities. 1 is, the world's on fire. 5 is, fix this when you can. Now, side note, giving this to users, have a separate one if you're going to give it to users. So if I was going to give users the opportunity to set a priority, I'd have user priority and priority. And the reason why is because users will say that everything is a 1. Everything is the most important thing. And when you go through and triage, you would probably go, you know what? The fact that you lost your spare power cable is not a world-ending emergency. Let's go ahead and bump that down to where it should be. But you can still show the user that you've, seen their priority or something like that. But for this, we're just going to have one priority. Date completed, date time 2. And date created, date time 2. If you don't know, SQL has date time and now date time 2. Date time 2 is the one you want to use because date time they wanted to fix it because it needed to be improved. And so they create a second date time called date time 2. The reason why is so it doesn't break compatibility with databases that use date time. So therefore we have date time 2. That's the one to use. Okay, now for date completed, we'll leave that as nullable, but this one is not null, the date created. However, we're going to say get UTC date, like so. We'll wrap that in parentheses. That's going to be the default value for that. That's going to get the UTC date and time for when it was created. That way, when you create a record, you don't have to put date created in. It will automatically populate with exactly when that record was created. Now, title and description should both be not null. We have a primary key identity for the ID that's going to have an auto increment. Notice if we look here, we'll see that identity 1-1 means it starts at 1 and goes up by 1 every time. So we're good there. So it looks like we're set here. Let's go ahead and apply these changes. It's going to say, here's what we're going to do. Go ahead and publish this. Okay, hit close. So now we have our tickets. And there's all our columns. Cool, we're all good. That means that now we can create store procedures. Now, some people don't like store procedures. Some people say they don't want to see a store procedure. I do. And the reason why is because of the fact that too often what happens is that people will create if they use Dapper, they put select star in the code. You shouldn't do that. You need to have a call to, in my opinion, a call to a store procedure. Not because you want to put business logic in the database, but because of the fact that you want to put that call in the database where it can be optimized, it can say somewhat optimized if it's an ad hoc call, but not nearly as well as if you put it in the database. And the fact that it's much easier to track down when you're looking at which database calls take them, cost the most. You can very easily see which ones, because they're being called by their store procedure name as opposed to an ad hoc query. That's another reason you are tuning your database, right? And then also because of the fact that they're now in source control and they're part of the database in source control, not part of your code in source control, right? So, okay. So now we have our store procedure. We're going to create store procedures here, which to do this, what I'm going to do is I'm going to actually say new query. I'm going to generate it this way. This is one area where it'd be nice to have the tool that we have for the table. But store procedures are not that hard to create. So let's just create it by hand. Create procedure. And we're going to say dbo.sp. People get confused here. Don't create sp underscore because that is going to confuse the system with the store procedures in the master database. So don't use that. Just use sp for store procedure. So that's what I do. And I say store procedure. I'm going to say the table name is tickets. We want plural for this one. Tickets. So tickets get all. And I'm going to say as, I want to not do the uppercase. So begin, end, and I'm going to say select star from dbo.tickets. Okay, now select star. Everybody freaks out about select star. And yeah, you probably should change that at some point. The good news is if you put it in a store procedure, you don't have to worry too much about it because you can change it as long as you change it in a way that doesn't break dependencies, right? But this is fine because we're just creating it for us. Oops, I hit save. That's not what you're supposed to do. Say run. So this is going to create our first store procedure. So command completed successfully. We come down here to store procedures and hit refresh. We'll see that we have the get all. And now if we were to execute this, so to execute a store procedure, say exec. And it's like, hey, I don't know what that is because it hasn't yet updated the cache. No problem. We can still run it. And it ran. And it's now just, empty results because there are no tickets yet. But it did see ID and ticket title and ticket description, etc. So we're good there. Okay. So it would have been nice if actually I can undo this. There's a pattern here. So I'm going to say get. And I'm going to say here at, and let's say ID int. And then here we can say where ID equals at ID. Now, this is another important point. It doesn't matter here because it's an integer, but with Dapper is going to pass in a string as a varchar typically. And if you're going against an nvarchar table, that can cause a conflict. And so what you want to make sure you do is you use types. And so it knows, hey, I'm passing this in as this type, and it'll make sure it's that type. Again, integer, it doesn't really matter. It's going to map it to an integer. But now you know that it's the correct type. Again, another reason why you use store procedures as opposed to select star from tickets where first name equals Tim or something like that, because it's going to convert that Tim to a varchar, and you want to make sure you're using the correct typing. Okay, so now this is going to create a store procedure that's the get. So I have a get all. We're doing basic CRUD operations here, right? So we have a get all, and that's going to do the get everything, but the get is going to require an ID, and it's going to return just that ticket. So that's the get all, get one, essentially. But let's run this. Make sure you don't highlight anything when you're running this, because otherwise it just executes what's highlighted. So there you go. And now we can do this over, and we're going to say insert and we can pass in not the ID, we don't need that, but, and here's where I open up the table, the ticket table. There we go. For some reason, it hid the columns for a bit. Oh, I scrolled. Evidently, it collapses that. That's kind of interesting. I hadn't noticed that before. But anyway, there's the columns, and we're going to use that because it tells us, oh, goodness, Tim needs to modify the table. Edit data table, because since I put all of the, well, that's interesting. Nope. I want to modify table structure. There we go. You probably yelled at me, and I probably wasn't listening. So let's kill this. We have ticket title. It's not an integer. That should be either a varchar or nvarchar. I'm going to say nvarchar 50, and this is the nvarchar max for a description. And the reason why we're going to change this is because, well, first of all, you have a string for your ticket title and description, non-integer. That should be a duh moment. But I'm going to say nvarchar, not varchar. And there's a difference here. Some people don't know what the difference is. Varchar and nvarchar both hold strings, but nvarchar holds Unicode, which allows for a much wider character set. That includes emojis. That includes characters from non-English, like not ABC kind of languages. So you're talking about anything with an Asian language or similar that would, Arabic languages. These are not in the normal ASCII character set. And I know that varchar is technically not just ASCII. It's a little bit different. It has a few more, but it's roughly ASCII, as opposed to nvarchar has the full Unicode. So I'm doing Unicode because, again, emojis, that's one that probably is going to pop up at some point. And also, again, supporting other characters, maybe they're in messages. So if you have an error message and it had a character that's not ASCII, you don't want to have those little square boxes. You want to actually see what the message is, so you can at least Google it or ChatGPT it. So nvarchar for both of these. It does mean it takes up double the space on disk compared to varchar. So if you're in a massive database, that can have a difference. And so you do want to think about what you allow and don't allow. There we go. Apply changes. And if that had data in there, of course, it would cause problems. You might have to drop and re-add, but that should be fine now. So now we have our columns, and they're the right types, which is great. And there's a reason why I open this up and display the columns, because now when I am creating my store procedure, I can say I want ticket title, and I'm going to say nvarchar 50 because it's right here. And I can see nvarchar 50. So I know what the type is. Ticket description, nvarchar max. And I want I don't need date created, date completed, so I just need priority. And that would be an int. And I could leave priority off if I wanted to. I could say, or I could say equals 5. That way I have a default value if I don't pass it in. Okay, so insert into DBO tickets, and let's get rid of the where clause here. I'm going to say ticket title, ticket description, and priority. And then values at ticket title, at ticket description, and at priority. Okay, so knowing how to write SQL, very important. Very important. If you're going to work with SQL, you should know how to write it. And yes, you don't have to know all the syntax. And yes, you can, mess things up. I will mess things up. Obviously, I messed up create a table because I created integers for text fields. But you really should know how to navigate around the basics of T-SQL if you're working in SQL, because if you work in a SQL, you should be in a SQL database. You should be understanding the performance of it. You should be testing out what is my least performant queries. And you should be doing this in production where it actually matters. Sure, first you do it in development to see if, what works and doesn't work, but you should be testing out in production. You should be reading the execution plans, etc. So you should know how these things work, because if you don't, you will have performance problems. It's almost guaranteed. You will not luck your way into a good SQL database performance. It just won't happen. So when we talk about making your apps performant, one of the primary ways you can make an app performant is by making the database performant. And you can't just say, well, I'm going to use Entity Framework and it's going to do it for me. No, it's not. Which is why if you use Entity Framework, you should know how to do this even better, because it's even harder to make sure you're checking your performance when you use a tool like Entity Framework. So you have to do even more work in SQL. And if you're like, I don't know SQL databases, therefore I'll just use EF, well, that's actually the wrong way of going about it. Again, you're going to cause massive performance issues. I've got videos on that. We don't have to go into more depth on that, but I want to make sure that we're clear on this. You should know how to work with your SQL database if you're using a SQL database. If you're using a different database type, Mongo, SQLite, MySQL, doesn't matter. You should know how that database works and how to optimize for that database. So, or that database product. So make sure that you know how it works. Make sure you know more than just, I can create a table and get data in out of it. Otherwise, you will have performance problems. Your app will have performance problems. And these performance problems won't show up until production. They won't show up in development because you don't have enough going on in development to really have the performance problems you will in production. So, okay, soapbox over. Let's go ahead and execute that, and it executes successfully. Cool. So now we're going to do an update, because update is kind of like the insert. We're just going to take all the values, and this time we're also going to take in the date created, actually date completed. And this is a date time 2. Date time 2. I don't like the uppercase. So we're going to put comma at the end. Okay. So this takes in date complete as well. Now, I'm doing a really simple update that says, hey, pass all the values back. That's probably not what you're going to do in most cases. Now, this works because I ask for the data, I give it right back, and it's going to update those data points. But I'd probably do in a production environment of any size is I would have different updates. So we'd say, instead of update, say mark complete, and it would just mark the record complete for the ID. And we could say update priority and just be the priority update for this table. So I wouldn't have just one query or one store procedure that's all the updates, but this is what we're going to do. So update. And then we come down here. Here's another piece of wisdom that is hard learned. Put your where clause in first, where ID equals at ID. So the reason why I do this first is otherwise you get talking, you get doing things, you get a phone call, you get text, whatever, you get distracted and you forget to put your where clause, and you update it and it runs. And it's great. And the first time this is called, it's going to update every single record in your database. And you're not going to find out about that until after you've done it and after you have that, oh no, sinking feeling in your gut, hoping that this thing didn't run when of course it did. So don't do that. Don't make that mistake. Put your where clause in first and then go back and put your values in. So ticket title, set. Ticket title equals at ticket title. Ticket description equals at ticket description. Date completed equals at date completed. Priority equals at priority. Okay, there's your update statements. And you can actually do something like this and then tab in one. So you can see what the set is, and reads clearer. Okay, so there's our 4 values for our update. So we can go ahead and run that. And again, don't hit save, hit the green run. You can also come down here to store procedures and refresh and make sure you've got your values here. Okay, the last one we're going to do is we need one more, and this is for delete. And there's going to be some irritation or at least a discussion around how to do this. Delete tickets where ID equals ID. This is a full delete. You don't always want to do that because sometimes you say, hey, I want to recover that. And it's like, well, that's too late because it's gone. Or you have this problem where you have a history table where you have a history of all the things that you've done and you want to reference back. Well, if you delete the ticket and it has a history, that history points to an ID that doesn't exist. And that can be a problem. And so you'd either have to delete, cascade delete all of your history, or you'd have to say that those history records are unmoored from an ID. And neither one is a great option there. So sometimes what you do is not actually delete, but you do a soft delete where you mark it as date deleted and put a date deleted value in there. And then what you do is after a certain length of time, you go through and delete for real all the records that are after a certain date or before a certain date, right? So you'd say, hey, any record that is 2 years old or older, go ahead and delete those records and all their associated records or something of that nature. It depends on how long you need to keep data for, et cetera. We're just going to have a full-on delete. So if you delete it, it's gone. Okay, so there is our 5 store procedures. You won't have exact store procedures. Some people get really caught up in this, the idea they have to have all these different store procedures for every table, and don't do that. Don't just say, because I have a table, I have to have these 5. Because first of all, like I said with the update, you might have multiple update store procedures for this table, or you might have a get that doesn't just get tickets, it also gets tickets with their associated, user associated, whatever, and do multiple joins to bring in all the data it needs. You don't have this one-to-one relationship. You've got to figure out what you need for data and then go create a store procedure for that. The cool thing about using not this way of doing things, but using the database project is that it's associated with your C# project or connected. So you can see, hey, I need this data. Let's go ahead and create a procedure for that. And then just put it right in the project and it updates with your code when that code needs it. It's going to have it in the database. So some cool stuff there, but just make sure you don't get so caught up in the idea that I'm going to have it this way. There's a lot more complexity around databases than just being a one-to-one relationship or this is the way we always do things. Okay, so now in theory, we could make calls to this if we wanted to. I'm not going to create tickets for now. I'm going to leave that alone. We're going to do that. Actually, you know what? Let's go ahead and create some tickets just because of the fact that I want to have something for when we wire this up to the API, which will be coming up soon. So let's go ahead and I'm going to do an insert. So exec dbo.sp. Actually, you know what? Is this a refresh button? No, but let's do this. Let's close this out. Don't save. And I'm going to create a new query. I don't know what the refresh is in this version. I know it's like Control-Shift-R, I think it is for SQL Server Management Studio. I forget. It's been a bit. I do it by memory sometimes, and I don't remember the keywords. But if we do exec dbo.sp, nope. So tickets, sp tickets underscore insert, and we're going to pass in the values. The value is going to be my first ticket. This is an easy one. and it has a default value, but we're gonna let's pass it in with no value for the priority because of the fact that there's a default value. So let's run this, and it says, oh, I use double quotes. Let's use single quotes. My first ticket, that should be correct. Nope. Let's do this. Nope. I'm going to look at the store procedure first. Script is execute. We can do that. Yep. Execute ticket, the ticket title. Interesting how it does that. Okay, set parameter values here. We can do something like set ticket title equals my first ticket, and set ticket description equals this is an easy ticket. Okay, and we're going to take off priority. We will make sure we test that we can call it without the priority. Let's just execute this and just see if we have, yeah, one railroad affected. I'm not sure what I was doing wrong on the other one, but let's go look at actually, you know what? No, let's do this. Let's come over here and say execute ticket or execute store procedure. And we're going to say get all and run that. And my first ticket. This is an easy ticket. There's a date and no completed date, priority of 5. Okay, so if I were to say get and pass in 1, there we go. Gets the same value. Okay, if I pass in 2, it's going to return no records. So that is working too. Okay, so let's do this. Let's do 1 or 2 more. My second ticket. This is a hard ticket. And I'm going to pass in priority int. And I'm going to say set at priority of 2. Okay, and then I don't love how I've done this, but we'll do it manually by hand in just a minute. There's another insert. We'll run this, and cool. And now if I do the same call again, we get my second ticket. This is a hard ticket, and the priority is 2. And if we do the get all and run again, there's our 2 tickets. Let's do the insert here. And I forget, I believe it's just the fact I put parentheses around it. So my third ticket, and we're going to say this is a medium ticket. And I'm going to say 3. So that should execute that. Let's go ahead and execute. It executed correctly. Okay, so that was just my bad about putting the parentheses around it. We can say, I can do select star if I wanted to. Star from dbo.tickets. And I can just highlight this and run it. And it only runs this, not this too. I highlighted just that code. So there's my 3 tickets. If I ran it again, you're not going to see 4 because it's just going to have 3 because it's not running this part of it. Now, just be careful of this because if you highlight the wrong parts, like if you were to do, and this is a really scary one, delete from dbo.tickets where ID equals 1, and you were to go, let's run this. That's going to delete everything because you've highlighted just the delete and not the where clause. So be careful of that. Be careful of relying on the highlights without being very careful what you highlight. Okay, so that's it. That's what we're going to do for this video. We're just going to set up this very, very simple database, 1 table, 5 store procedures. We put a couple of sample records into the table. That way we're ready to wire up the API and start having the basic CRUD operations go through the API, which then we can then put it into the front end and create a little UI for it, maybe some styling, etc. But that's it. That's all we are going to do for the database. So this is part of the ticket app part of this course. We're actually building a little app here. So stay tuned for the next lesson. If you missed the previous lesson about the Aspire setup, go ahead and check that out. Make sure you're up to date there. You can also this stuff right here. I won't include this, but coming up later, any source code we do will be attached to the descriptions of the videos. So you won't get the database. Probably, maybe I'll get ambitious and put the database there too. But for right now, you'll get just the source code for the changes we do to the actual application. Okay, and that'll be in the description. All right, thanks for watching. As always, I am Tim Corey.